Next problem. In a year's 956 birth in a town A, of which 52.5% are male, while in a town A and B combined this proportion in a total of 1406 birth was 0.496. Is there any significant difference in the proportion of male birth in the two towns? So N1 and N2 be the number of samples of birth in town A and B respectively. Given N1 is equal to 956 and the combined male birth A and B, so they have given combined male birth, right? That is equal to, that is N1 plus N2, right? 1406. Therefore N2 is equal to 1406 minus N1, so you will get 450. So N1 equal to 956, N2 is equal to 450. So P1, P2 are the sample proportion of male birth in town A and B respectively. So P1 is male birth, they have given in percentage directly, right? 52.5, right? That is equal to 0.525. But to find B2, but they have given combined proportion, right? Capital P, that is the total, right? So P is equal to 0.496. So Q is equal to 1 minus P, that is equal to 1 minus 0.496, that is equal to 0.504. We know the combined proportion capital P is equal to N1 P1 plus N2 P2 by N1 plus N2, right? So N1 P1 plus N2 P2 by N1 plus N2 is equal to 0.496. Substituting the values, 956 0.525 plus 450 P2 we don't know, so P2 divided by, so combined one N1 plus N2 is equal to 1406, that is equal to 0.496. Therefore P2 is equal to 0.434, right? So defining hypothesis, so H naught, there is no significant difference in the proportion, right? So P1 equal to P2. And an alternate hypothesis, there is a difference, so P1 not equal to P2, right? Level of significance 5%. Test statistics, Z is equal to P1 minus P2 by root of PQ by N1 plus PQ by N2. Substituting the value 0.525 minus 0.434 divided by root of PQ divided by 1 by N1 plus 1 by N2. So 0.496 into 0.504, 1 by 956, 1 plus 1 by 450. So that is equal to 3.193. Therefore calculated value of Z is equal to 3.193 and tabulated value, this is the standard value at 5% level, 1.96. So conclusion, calculated value is greater than the tabulated value, therefore H naught is rejected. So there is a significant difference in the proportion of male birth in two towns A and B, right? That is the conclusion. Next problem. In two large population there are 30 and 25% respectively of blue-eyed people. Is this difference likely to be hidden in sample of 1200 and 900 respectively from two population, right? So they have given is there difference likely to be hidden sample of 1200 and 900 respectively from the two population, right? Two large population there are 30 and 25% respectively blue-eyed. So first we are taking capital P1 and capital P2 population proportion of blue-eyed people. So they have given large population count, right? So 30%, P1 equal to 30% and P2 is equal to 25%. So P1 equal to 0.3 capital, right? Capital P2 is equal to 0.25. So Q1 equal to 1 minus P1 0.7, Q2 is equal to 1 minus P2 0.75, and the sample. So second line, to be hidden in sample of 1200. So N1 equal to 1200, N2 is equal to 900. Defining hypothesis. So sample, there is no significant difference between the sample. They are asking, is there any difference likely to be hidden in samples? So that is why. So defining hypothesis like that. So there is no significant difference in the sample. And alternate hypothesis, there is a significant difference, right? Level of significance we are taking 5%, but they have not given. Test statistics, Z is equal to, so instead of small p1 p2 you have to take p1 minus p2 capital, right? Divided by root of p1 q1 by n1 plus p2 q2 by n2. Substituting the value 0.3 minus 0.25 divided by root of 3, 0.3 into 0.7 by 1200 plus 0.25 into 0.75 by 900. So you will get 2.551. So calculated value is 2.551. So tabulated value 5% level 1.96, right? So conclusion, calculated is greater than tabulated, so it's not rejected. So there is a significant difference between the sample, right? Thanks.